Let's talk about physics. Yes, from cosmology and the universe to the quantum world of atoms and molecules. From Newton to Einstein with a lot of curiosity.
Hello, I am Anya. Welcome to our show. Let's talk about physics.
Hello, I am Mateo. Welcome to our show. Let's talk about physics.
In the 15th episode of this series, let's talk about the details about collapse of exotic waves due to strong repulsive electrical fields. In previous episodes, we discussed how strong attractive electric fields could produce common quantum waves collapses. We also covered the gravitational atom model.
Imagine a quantum particle trapped in a box, the simplest model for spatial localization. Using a Grave de Peralta's equation, we find the positive relativistic kinetic energy. This energy is a rough estimate of the internal kinetic energy in gravitational atoms. For potential energy, we consider the negative gravitational potential. The total energy of the quantum particle with mass is the sum of kinetic and potential energies. The quantum wave size is estimated at the minimum energy level. This model offers a glimpse into the complex world of quantum mechanics.
Anya, I agree with you.
Imagine repeating calculations, but first, swap positive kinetic energy with negative energies of exotic solutions. Next, replace negative gravity potential with a positive repulsive Coulomb potential. Then find a local maximum of total exotic energy. The result? Mind-blowing. The exotic wave of a charged quantum antiparticle collapses if its charge exceeds Planck's charge. That's about 11 times the charge of a positron. Physics just got a whole lot more interesting.
Dear Mateo, you are well informed.
In this way, it was determined that the exotic waves of cloud of charged antiparticles, like positrons, can't exist if its total charge exceeds the Planck charge. This is because the exotic quantum wave of the cloud collapses. A cloud of more than 11 positrons becomes a classical antimatter object. This explains why only a few lithe antimatter atoms exist. Notably, this wouldn't happen if the non-relativistic Schrödinger equation was used. The absolute value of the relativistic kinetic energy is smaller than the non-relativistic one. Therefore, large positronic clouds lack enough kinetic energy to compensate for potential energy. The paper Classical Fields and the Existence of Classical Quantum Frontiers, published in 2025 on social media X, confirms this result. Moreover, Grok, the AI of X, confirmed its validity. This result was interpreted as the existence of a quantum classical frontier at the Planck charge for antimatter. This is because the quantum antiparticle gets nude after the collapse of the exotic quantum wave. An antiparticle without waves is a classical antiparticle.
Anya, I agree with you.
Imagine a cloud of electrons, more than 11, swirling in quantum harmony. This means a cloud of electrons with more than 11 electrons continue being quantum. Therefore, there are stable atoms with more than 11 electrons. Thanks to Professor Grave de Peralta, we know why. He proposed that their repulsive potential energy in exotic states isn't positive, but negative. This keeps atoms with more than 11 electrons stable. Antiparticles and particles differ in their exotic wave reactions. Strong repulsive fields influence them uniquely. So, stable atoms thrive, defying collapse. Quantum magic, right?
Mateo, this is a sensational result and interpretation. This makes a theoretical prediction that agrees with a huge volume of observational and experimental data.
Ever wondered why there's no life made of antimatter? Life as we know it is made of atomic matter, and so are we humans. If aliens exist, they'd be made of matter too. Why doesn't biological antimatter exist? It's a great question. The easy answer? Biological antimatter can't exist without antimatter. And there's no antimatter because, well, the scapegoat. But Professor Grave de Peralta has a different take. He says life made of antimatter is impossible without antimatter chemistry. So, no antimatter chemistry, no biological antimatter. Fascinating, right? Stay curious.
Mateo, this is a sensational result and interpretation. This makes a theoretical prediction that agrees with a huge volume of observational and experimental data.
Anya, you know a lot. Let's summarize our discussion today.
Imagine a world where strong repulsive electrical fields can collapse antiparticle exotic waves. Yet, these same fields extend particle exotic waves. This is the essence of Professor Grave de Peralta's groundbreaking hypothesis. Current field theories excel at describing matter, but they predict a non-existent antimatter world. Could Grave de Peralta's hypothesis introduce matter-antimatter asymmetry into these theories? It's a revolutionary idea that challenges the very foundation of our understanding.
Mateo, we should now summarize the complete series.
Wait, Anya. No so fast. We will talk about this stuff in future episodes of this series. This is enough for today. Ciao, Anya. I love you and we love our audience. See you in the next episode.